All right, three, two, one, go. Hi, everybody. John Beckman, Professor John Beckman, Dr. John Beckman, the father of sin, the transgenic mother of sin, your hostess with the mostest. I had received some requests to clarify what it means to clone in frame. I have a whole video on what it means precisely to clone in frame, but I kept getting comment after comment after comment that was, well, you didn't actually show us how to do it. You didn't actually show us how to clone in frame. So the premise, just to review the premise of cloning in frame, is that there are three different frames through which a ribosome can read messenger RNA, and a shift in that frame can change the codons, which can mess up a protein. And so when you're cloning a gene for recombinant protein expression, the premise is that you have some plasmid, and there's a start codon programmed into that plasmid oftentimes, and that start codon is perfectly distanced from some promoter. And in bacteria are very sensitive to the distance between the promoter region and the start codon. And so it needs to be exact. And so you don't fiddle with that position. You don't fiddle with that positioning in recombinant protein expression. Okay. And so oftentimes the multi-cloning site is downstream actually of some start codon. Okay. And so in the multi-cloning site where you have all these different restriction enzymes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., your job is to, if you're going to clone in frame and you're going to make something that's going to get expressed, your job is to pick a specific restriction enzyme. And then when you do your cloning, you have to make sure that whatever you insert is in perfect frame with that original start codon. You cannot shift the frame, otherwise the protein will not work. Okay. And when you're cloning, when you buy a plasmid, so for example, PBAD, which is what we use in my lab, when you buy the PBAD suite of vectors, you don't just get one plasmid. You get a PBAD A, a PBAD B, and a PBAD C. Okay. And each of these three plasmids are in a different frame. Okay. And the reason I didn't want to show how specifically to do this is because it's a context specific example. So what I'm going to show you today is not going to, the concept will be the same, but you're going to have to figure it out for yourself. Like I'll show you how to do it, but it'll be different for every time you make a clone. Okay. So let me show you how to properly clone in frame now that you understand what that is. So I just have an example protein here, or a gene, HUP-A, which codes for the HUA subunit of a transcription factor in E. coli. We're going to try to clone this gene into the PBAD vector. Okay, so I downloaded from AdGene the three variants of PBAD, the A, the B, and the C. Okay, so I essentially just downloaded the whole sequence of the plasmid. If you're actually going to clone in frame, you got to have that. So get the sequences. Okay. Now this site CCATGG, that's an NCO1 cut site. This is the start codon. This ATG that's inside of the NCO1 site, that's the start codon. So whichever one we clone has to be in frame with that start codon, okay? And downstream of this start codon is the multi-cloning site. So here I've marked yellow. This CTCGAG, that's the Jo1 site. So the multi-cloning site starts right around here, downstream, as I said, from this start codon. And whatever we pick or clone in has to be in frame. Okay. So again, just a quick example. I'm going to use Jo1 as my cutting enzyme, and I'm going to design a primer that would clone in frame. Okay. So in order to do restriction enzyme cloning, to do the primer design, you need two primers. You need a forward and a reverse. Okay. Your forward primer is going to start right at your start codon. You're going to want to end it with a G for that CG clamp. I don't know if this is going to be perfect, but I'll show you how I check my primers. I go to oligocalc. I paste my sequence. I hit calculate. I check the salt adjusted annealing temperature, 56. That's about perfect. I check the self-complementarity. There's no hairpins. That's great. Okay. So this is going to be a perfect primer, a base primer for cloning in frame. Okay. Now you would also design a reverse primer. Let's see what be something like this. Let's see what this would give us. 59. It's got a hairpin. It kind of stinks, but like we'll go with that because we're cloning this gene. And actually, when you're cloning in frame, the reverse primer is not really the part you need to modify. It's always the forward primer that needs to be modified. So just consider this our like reverse primer. And now let's build the additions into our forward primer. So our forward primer, it's got ATG, that's the start codon for our gene. This is what needs to get in frame. And remember, I decided we're going to clone with the GEL1 site. So we have to add in our GEL1 site, which is CTCGAG. Okay, that's our restriction enzyme site. And whenever you're cloning, you need to add 4 random bases to make sure that the restriction enzyme has something to grab onto to cut. So let's just try AAAA. Okay, so I would take this primer. I would recheck this to make sure that I haven't made it worse. Sometimes when you add that AAAA or random 4 bases, you can get bad hairpins, which can be changed if you want. This looks okay. Okay. So this is a good primer. Okay. It's got our annealing site that's gonna bind to the start codon of the gene. It's got this CTCGAG cut site. Okay. So when this gene actually clones in, you have to understand that now these are 2 codons that are going to get stuck in. Okay. So where this is going to hit, let's copy this sequence. Where this, if our reaction actually works, where this is going to hit is right in front of that start site, right in front of that CTCGAG site. So if this works, it's going to pop in right there. Okay. And let's try it for the 3 different plasmids. Here's the PBAD-B. It's gonna, if it works, it's gonna pop in right there. And in the C, if it works, it's gonna pop in right there. Okay. Now, here's what I guarantee. I guarantee, because of how they design these, only one of these is gonna be in frame. I don't know which one it is. We're gonna have to check. So now the way that you check, go to Google, go to your Xpesi translate. That's my favorite one. Okay. We're just going to translate these 3 sequences. So let's try the A. So this, remember the green, that NCO1 site, that's the start codon. Remember, there's actually multiple start codons going on here. Okay. The NCO1 site is the start codon in the vector. Okay. And upstream, there's going to be a start codon for our gene. Okay. But the actual start of the translation of our protein is going to happen at that NCO1 site. And the reason is because there's this his tag, like it's automatically adding a his tag. Okay, there's the his tag right there. So let's see if this is in frame. So you start at that green start codon and the NCO1 site, take the rest to the stop codon, and let's translate this. This is in the A vector. This one is in frame. See, look, there's the M start codon, there's the his tag, and then my protein probably starts right here, MGRDL. No, wait, this is a tag. Did I get the translated sequence? Let me just see quick what the actual coding sequence in proteins is. MNK. So this is the actual HU protein, MNK. Now let me go back. Paste in that theoretical construct. And it's in frame, and here's the start of my gene. So it's adding actually a significant chunk, an N-terminal chunk, onto the expression of my protein. And there's some reasons for that. The PBAD vector is adding this his tag, which we want, and it's also adding a enterokinase cleavage site so that this tag could actually be cleaved off if you wanted to. Now, this is actually can be a pro or a con. In some cases, I don't want all this extra stuff in front of my protein. And so in some cases, I will actually clone in right at the NCO1 site with exactly what I want. to not have all this N-terminal extra stuff. But if you want all these extra bells and whistles, this is how you do it. Okay, so now let's just to prove it. Okay, so actually the one that was in frame was the PBAD A. So that would be the one that we would want to clone into with this forward primer that we designed. But just for validation, let me show you that the other ones will not be in frame. Okay, so if we were to clone into the B plasmid, here's the sequence from the B plasmid. It's not in frame with that start codon. See, that start codon is going to run and it's going to hit that his tag and that enterokinase cleavage site, but then it frame shifts. And our protein, which is this one, which is in frame 3, is not in frame with the frame 1. So it's not going to work if you clone into that B. Okay. And just to validate for the C, we can do the same thing with the C. Clone it in or translate it. Ditto, same problem. It's not all in the same frame. Here's the start codon from the vector, coding that N-terminal tag and enterokinase cleavage site. And then our actual protein that we want is actually in frame 2. It's in the wrong frame. So B and C would not work. This would only work if you cloned in PBAD A. Okay, so that's how you do it. Now, like, this is a very specific example, like with this one protein that we're cloning into this one vector. If you want to generalize this concept, the simple idea is that when you add these restriction sites, these restriction enzyme sites, if you're cloning at things that are upstream of that vector start codon, you have to make sure that whatever your restriction sites are adding in, or whatever tags you're adding in, say you added some extra bases here, you might add some modulo 3 number, so some number of base pairs that's not divisible by 3. And if you do that, you're shifting the frame. And so you need to shift the vector that you're cloning into accordingly. I can't tell you exactly what that's going to be. It's going to depend on your primers that you're doing. It's going to depend on what kind of tags you're putting in, how you're cloning your gene, what restriction enzymes you're using, etc. But the premise is you look at what's upstream of the start codon of your protein, and you have to pick the 1, 2, or the 3 plasmid that puts it in frame with the vector. And the way that you check that is you literally just paste the sequence that you're cloning, the exact sequence, right after that restriction enzyme site. You can just check the translation in the 3 different frames. That's it. Hopefully that was not too complicated. Have a good day. Bye-bye.